Right. Hello, everybody. Welcome to week 7. We are almost at the home stretch. So, today we will be going over software design, or in general, how you should design your software, in our opinion. There's a lot of opinions out there in terms of how software design should go, but we'll try to give you we think you should design your software the best to give you the best chances of either understanding your own code as well as having other people read it as well. So, as a quick recap, last week we went over a bunch of review. We did some classes here and there. We did some worksheets on our data structures and answered a bunch of questions from everybody. Hopefully that was a nice review session for everyone to kind of really drill in that fundamental idea of the different parts of computer science into your head. Of course, if you have questions still on any of the parts, feel free to ask us in the chat. All right, now let's go over software design. Okay, first of all, we need to talk about what software design actually means. So, in essence, software design is how you would structure your code. In terms of when we talk about, for example, classes and objects or functions and multiple files, how structuring your code can give you a lot of benefits into working with your code easier, especially when your code becomes more and more complicated and you're working with a lot more code. It is very important to do proper software design so that you're basically helping out your future self. And throughout this week's lesson, we will provide you a lot of different examples on how you can use some of the knowledge we have taught you in previous weeks to design your parts of your software correctly, or at least in a way where it makes it easier for you in the future. Now, there are a bunch of different parts about software design. Every time when we talk about software design, some of you might have the idea inside your head, oh, that's like I'm planning out a whole project. Like, for example, if I'm making a game, I would be planning out all the enemies, all the skills, the battle system, etc. Software design covers as little as what you should name a variable or a function to as big as the overall design. And honestly, you can apply software design to many, many different parts of your project. Okay, let's go over some examples. So, a couple things to know here. Number one, you still want working code. We always talk about readability. And when Lucia and I talk about code readability, what we're talking about is when you read your own code, how easy is it for you to understand what's happening inside of your code? Or if you're working with someone else, which many of you probably will if you decide to tread down further into computer science, how easy is it for other people to read your code and work together with you? Or how easy is it, vice versa, for other people to read your code or to you to read someone else's code? So it's very important to design your software and make it readable enough to work collaboratively, because computer science is moving more and more towards collaboration in the future. It is getting harder for one person to do everything. And And you'll find that by working together collaboratively better, you'll be able to make greater things and learn more about computer science. So, another thing about software design, by taking some time and thinking about how you should design certain parts of your program, it will actually make your job a lot easier in the future. For example, if let's say we were designing a shop and we have already thought about how players would buy items from us, then in the future, when we're going to write that code, that part of the code is already sectioned out for us by you in the past. And this type of software design is very important because it kind of makes the software development process smoother. Instead of, let's say you're designing something and you're writing something, and middle of the way, you think to yourself, oh, yeah, maybe I should have added this. Oh, but I can't add this because X, Y, and Z. Then you might find yourself in a little bit of a pickle. I'm not sure if any of you all in the audience have experienced this in the past, but I certainly have experienced situations where I realized that in order to do something that I wanted to do, I would have to rewrite a lot of my code. And software design can really help you prevent that from happening. You're basically doing a little bit more work today to prevent a lot more work in the future. Right. And just one more thing about software design. So I know I talked a lot about the importance of software design, why it's good. Let's talk about how not doing software design properly could potentially be bad for your code. One of the most important things is that when you miss out on some parts of software design, you may find that you can find some bugs or issues within your code later down the line. And doing these type of pre-planning ahead of time can help you prevent a lot of issues or bugs. Here in the picture, you can see we have a cat um, squishing a bug. That's you, and that's your bug in the future because you didn't do software design. Now, don't be too concerned about doing everything ahead of time. There's a really fine balance between how much you spend on design and how much you actually code. So let's go into some examples. Okay, first example, we're going to be talking about some overall higher level organizational concepts, such as how you should write certain parts of your code and where you should put them in order to give you better design overall. Let's start with functions. So, if we think back to maybe many weeks ago, when we first began to talk about functions, one of the things that we have talked about, why functions are so important, is that functions allow you to take an action or a part of your program and insert that into a single line with potentials of different parameters entering the function, giving it slightly different behavior. But overall, the function is supposed to represent a set of behaviors. But how should you actually organize those functions? So the idea here is we always try to keep our functions short and succinct, and try to keep the amount of things that happen within your function limited. So, what I mean by that is number one thing, you would always use functions to prevent duplication within your code. So if you're finding that you are copy pasting a lot of different parts of your code to do the same thing over and over and over again, even if it's like just a couple lines, it might be better for you to move that into a function and give it a proper name. You'll find that when you have a lot of these repeated calls, the function and its name can help you better understand which part of your code is doing what. So let's take a look at this example here. So in the example here, we have a function called get user input and then adding 3. So here we do a simple thing where we get a user input and then let's say we have a bunch more extra code here to be like, oh, did the user actually input a number or did they type some random name, or is the input that the number that they inputted like actually valid or something that we care about, et cetera, et cetera, et cetera. And then finally, we add 3 to it and we return the number. Now, this add 3 here is an example of an additional functionality that might really go into something that could be a lot more complicated. So, what is the idea here? Well, let's look at how we can structure this function that we showed in the past into two different functions here. So, because we're doing so much in the get user input function, where we are checking to see if the user actually put in the number, to see if the number is valid, to check a bunch of different things, this functionality gets a little bit complicated. And because it gets a little bit complicated, it's actually more recommended and more readable for you if you were to split this up into two different functions. So now let's look at what we have. We have a single function that says get user input. That's all it does. It just gets the user input and it makes sure that the user input is valid. And it returns it. And then we have another function here called add 3 to user input. Remember that the add 3 here is simply a demonstration of something a lot more complicated you can do with the user input that you're getting. But instead of putting everything into one huge function, now inside of our add 3 to user input function, we can see that the first line is get user input. Now it's more readable. We no longer have to worry about, oh, but what is the user input getting actually doing? How are we checking and validating everything? No, the get user input function already performs all of those validations for us. And by performing all of these validations for us inside of our add 3 to user input function, all we have to care about is the mathematical operation or whatever operation we want to do on that user input. Okay, now please raise your hand if you think that this set is a bit more easier to understand immediately reading it as compared to the previous set. Remember here that the biggest change that we did is that we took something that does two complicated things into two functions that does one specific thing. That is the most important part. Okay, I see some hands in the audience. That's good. So hopefully, all of you see the point that Lucy and I are trying to make here, which is keeping your functions succinct, and that provides you an easier understanding of what your code is doing. It's also easier to find issues in the future. For example, let's say you have a bug in where you're not validating the user's input correctly. Well, instead of going to this huge function here and trying to dig where you're doing the user validation, in the second example, we can simply go to get user input and then just look into that specific function. It's also much easier to look for issues. Okay, I realize that I have just talked very fast about a lot of things. I'm going to pause for a second here so that we can get some questions, if anybody has some, from the audience. Okay, okay. Do we have anything from Twitch chat? Ashley's typing. Mm, all good. Ashley said Wi-Fi acted up and missed some of it. Could I repeat it? Yeah. So the most important concept of how we can use functions to properly outline how we do software design in a very simplest sense is that you want to keep your functions fairly small and doing one specific thing or a few very specific things. When functions start to become a lot complicated, it is much easier for you to either create bugs or make it harder for you to find those bugs in the future. And that's why it is so important to keep things succinct and keep things simple. Hope that helps with an overall. Oh, yeah. So, one more important thing is about the function name. Keep in mind that names are very important. For a lot of people, they may just read the name. And if the name on a function is named well enough, then that might be good enough for another programmer to read your code and be like, oh, yeah, this is what the function does. Or something you might be discovering is if you write code and you don't look at it for a very long time and you come back to your code, you might find that you no longer know what you wrote. And, this is more common than you think. This actually happens to many of us. Keeping the names well written can really help you kind of go through the code and really understand what's happening immediately off of the name. So we have poorly named functions here as a joke, where subtract does something super cursed or add does something super cursed. Those are examples of bad names. Because reading the name, you might not know immediately of what's happening. And here's another function for a guideline of how you should name your functions. Let's look at this function here. This function does some kind of magic to numbers and stuff, I think. Uh, so obviously, this is a bad name, but why? Well, the biggest answer here is you simply ask yourself, okay, if I read the name of this function, do I understand what is happening? Or can I have a pretty good guess of what is happening? Even if I don't immediately understand how exactly goes on within that function. And if the answer is immediately no, then maybe that function needs to either be renamed or have it split up into smaller functions where you can give them names that really make sense. I, this name is also way too long. I don't think anybody actually wants to see this type of function in any code. All right, so let's go over classes. So, how do we properly structure what classes do? How do we properly give classes names? And what type of functionality goes under what type of class? Well, we're going to try to give you a couple of examples here to give you an overall guideline of what we would recommend you do when you're working with object oriented programming languages such as Python, and you'll find yourself start using classes. Simply put, a class should have a single responsibility to represent something. And that idea can be a little bit broad as well, or that idea can be very, very narrow. So, for example, we can talk about all animals as a single class, or can just talk about a cat. But when you're having a single responsibility for any given class, try not to add in any other functionalities that really wouldn't make sense for that class or should really go into another class. So the example here is, well, maybe animals shouldn't include functionalities where we would represent, let's say, a wall in a video game. Another example here is that we have a cat class that meows. Cats should meow, I think, but we also have another functionality here that does taxes. Well, unless you're defining a really smart cat that can do your taxes, maybe this do taxes functionality should go to a class like an accountant. But I don't know, your cat could be very smart and maybe they can do taxes. I would like that cat if it does. Okay, another point here about classes is that specifically we're talking about inheritance. In this case, the extension of the class. So, what that means is that we should write classes in a way where we allow classes to be either modifiable to other classes or be modified by other classes, which means generic classes can be used by more specific classes to have more functionality. So, for example, a cat inheriting from animal, or more specific classes can be can inherit from other classes here. Um, I see Shay jumping. Do you have a question?
Oh, no, sorry, just hyper.
Oh, no worries. Sorry, I lost myself. Where was I? Ah, yes. What is inheriting code again? So I don't have an immediate example here, but I can show you on this slide. Here we go. So let's take a look at these two classes. We have a very generic class called a player, and the player can perform an attack. Pretty simple and self-explanatory class. The player attacks something. Next, we have another class called Archer. Archer inherits from the player class, which means archers can attack. And that right here is inheritance. Inheritance allow any class to take after the functionalities and attributes of another class. In this specific case, the attack is being inherited by Archer from player. And this part specifically, it's very important because we're trying to show you extensibility here, in where player class is now extensible and is actively being inherited upon by Archer. These types of functionality sharing can make your code a lot more succinct and understandable. Yes, question from Aurora.
Uh, isn't that just defining a attack again in Archer, not the inheritance thing as explained in 2 weeks ago, I think?
Yeah, so here we are redefining attack. But something else to note here is that Archer extends everything from player. So, for example, player could have, its own hit points. Player could have its own attack and damage values, and all of those can be inherited over. And we could simply be overriding the attack.
Oh, right.
So, in that case, the extensibility here extends to the entire class, not just this specific function here that we're seeing. But yes, good point. We are overriding attack here, but everything else is taken over as well. So, to give you another example, let's think of a very simple archetype within RPG games. If anybody has had experience with, let's say, either World of Warcraft or you've had experience with Dungeons and Dragons in the past, then think of like the depiction of like a paladin, right? A paladin is someone who can like do tank stuff. They're very tanky. They're standing in the front lines protecting everyone, and they can heal. So when we extend a class called Paladin, we can take in functionalities from both a priest to give the Paladin functionalities of healing, as well as a warrior to give Paladin a functionality of being like that front line, like bulky protector. That's like a more gamified version of how we can use extensibility to kind of share a lot of functionality and code between our different classes. Hope that makes sense. So, next, we're going to talk about how to use different files to structure your code. Now, as you write more and more code, you'll start to discover, oh my gosh, I'm writing a lot of code in one big file. It could be like hundreds of lines, or maybe even thousands of lines, or tens of thousands of lines. I've seen files with way too many lines to count. And when you have files that big, it's really hard to stay organized and find where different parts of your code does what. In a lot of those cases, something important that you'll find yourself facing is, wow, I can't find anything unless I do like a control F and I type in something specifically to look for that phrase. Well, in this case, you can break up a lot of your code into multiple different files. So, for example, if you have a lot of classes, you can actually put each and every single one of your classes into its own file. And you can organize these files under folders. And you can organize the folders under other folders. Honestly, the organizational structure can be as detailed or as vague as it makes sense to you. In Python, having these different folders and organizing them in different folders are called modules. So here's a very simple example here. We have our main.py, which many of us, if you have worked with the worksheets, now you probably have experienced writing a lot of your worksheet answers inside of main.py. Here we're creating a folder called lib. This stands for library and is usually the word that we're using to describe functionality that we're taking from other files. And inside of lib, we have a file called util.py. Util is usually an industry short term acronym for utility. This can include pretty much any generic utility that you deem might be good to place into another file because they don't need to clutter up your main file, or their utility specifically used for a few classes and that's it. Let's take a look at how we would refer to these utility files and modules inside of your code. Well, Python will always look at your main.py as your root. When I talk about root, you can think of this is where your program starts. The way that you structure program files, such as using different folders and different file names, well, these can be directly referenced to within your code. So, for example, let's say inside of util.py, we have a function called generate percentage that calculates some kind of percentage. Well, this code might get a little complicated, or we just want to move this code to util because we're not using it all the time. In this case, we can use from lib.util import generate percentage and take a look specifically at how the index and the syntax works here. More specifically, if we have a folder structure, then the syntax that we will want to use is the name of the folder dot the name of the file. Very importantly here is that we are not including .py in any sense. Python by itself will generate a lot of these folder structures out for you. And let's say you had more folders under other folders. So like lib, and then another folder, and then another folder. Then you would access each and every single one of these folders by simply using dot. You can do lib.folder1, .folder2, .folder3. Basically, you would slowly go down using the dot into as deep of a layer as you have made your file structure to be. Okay, so that's modules, the simple way of doing modules. The idea here for modules, you may ask, wow, thanks for teaching me all about modules, but how do I properly order these modules? So you can use the same idea as we have with functions and classes, which is to try to keep the folder under one big idea or one big functionality. So for example, if I have a bunch of miscellaneous like math functions lying around, then I can move all of the math functions into one file and we can call it math_util or something similar. But the idea here is that by organizing all of these into their specific functionalities, into their specific data structures, into their specific data files, you are then more easily able to know where parts of your code are when things get complicated. And this type of organization can also help you find and prevent bugs. Okay, some more miscellaneous stuff. This is a bit more into your own personal preference, but Python has some specific recommendations for you. So Python has what we call a style guide. In a lot of programming languages, style guides are the programming language author's way of telling you how you should name certain things or how you should structure and organize the name and the code of your function, of your program overall. These different cases here are an example of naming conventions. We talked about naming conventions earlier, where we have different ways to name your function and different ways to name your classes and variables. These are just some of the examples of how naming can be represented differently in other programming languages. For Python, we want to use snake case. And what snake case looks like is every single word is distinguished and separated in the middle by one underscore. We also have camel case, which instead of using the underscore, you make every single word other than the first word capitalized. And it's called camel case because the middle capitalization kind of makes the name look like the hump on like a camel. So you can have like multiple humps if you have multiple words within a single variable. We have Pascal case, which is you capitalize the first word, the first letter of every single word. It's called Pascal case because this was originally derived from the programming language Pascal, which is very old, but sometimes still used today. We also have kebab case, which instead of using underscores, you would use dashes. And it's called kebab case because it looks a little bit like you took like a kebab skewer and then you like stuck it through all of the words. Different languages use different ways of stylization. No matter which way of stylization you use, if you choose to not use the Python recommended snake case within Python, the most important thing that I'll leave to everyone here is that try to keep your style the same. Even if you choose to use something unconventional, keep everything the same. Trust me, it's going to be very confusing for not only you in the future, but for other people when you mix and match styles. All right, so something else here. Sometimes, when all of you have been working in Replit, some of you might have seen, gotten some like squigglies underneath your code. And that is the programming linter yelling at you. Now, what a linter is linters are a specific program that tries to pick out certain stylization issues or naming issues or organizational issues within your code. Most of these within any linter are usually recommended in the style guide by the program's creator. So, for example, here we can see that we're having some indentation issues here. Python is one of those programming languages that really, really cares about indentation. And having different indentation can have drastically different functionalities within your code. Sometimes that part of the code might not even run, or it might run incorrectly because of the indentation. In these cases here, Python's linter makes an attempt to try to tell you, hey, something's wrong with the indentation here. Maybe you should take a look. In this case, our return variable on line 3 is indentated too far to the right. Usually, these things are pretty good to listen to if you're not too sure about how you want to exactly stylize your code. Most programming languages that you would be working in will probably have a linter. How you would set up that linter, well, it really depends on your programming environment, and that's something that you will have to look up. Oh, also, it's called a linter because we are picking out like lint within the code. So, like, pieces of fluff that we might not want to exist. Okay, this is our final note here that we want to leave everyone with, which is think about how complexity affects your program. Complexity may give you the sense that, oh my gosh, I'm doing something really good here, something really crazy. But in a lot of cases, complexity isn't always good, and sometimes it may be very detrimental for your program. And having too much complexity and too much abstraction can usually lead to code bugs. And that's where a lot of bugs show up within all the programs that we're using today. Think about the last time that you have received any program update in any of the programs that you're using. VR chat, Steam, Windows. Why do we always have so many bug fixes and so many program updates in the programs that we're using today? Well, that is because new programs or programs that are always being updated are constantly adding more complexity and more features into the program itself. Adding features is usually good because you can do more things, but adding features or more things you can do within the program tend to lead to additional complexity, and the complexity probably leads into bugs. No one's perfect here. Even the best programmers make mistakes, and those mistakes lead into bugs. And that's why we always try to strive to keep things simple. Because when you keep things simple, it's more obvious when you have an issue, it's more obvious when you have a bug. The principle here is called KISS, which stands for Keep It Simple, Stupid. That's me calling myself stupid because no one's perfect. We all make mistakes, and that's okay. Making mistakes is part of the human experience, but we can do a lot of things here for us to make less mistakes. And this design principle basically covers that. All right. Any questions from anybody covering anything that you might be thinking about in terms of program design or how you should structure something or why should I care about software design? Hopefully, I have made a pretty comprehensive case to everyone here. Yes, question here.
Is it common in enterprise environments for them to change up the style?
Oh, good question. So the question was, is it common in enterprise environments to change up the style? So the answer is no. In fact, even if the style is, let's say, incorrect or unconventional, it is actually better for large enterprises to just keep that incorrect style as now the correct style. Because when everyone's making the same mistake, no one's making a mistake. So it's very important for everyone to be on the same page rather than everyone reaching this supposed perfect future that probably doesn't exist. And Lucia can probably add on to that as well, but that is from my experience. Sometimes when you have a style change, it's usually something very small and it's usually dependent on some kind of functionality that that improves the code in some way. So unless there is like a large improvement that really justifies a lot of change, you probably won't see any style changes. It's better for everyone to be wrong. Hopefully that answers it. Yeah. Okay. Any other questions? I see some people typing. Gonna check Twitch real quick. Anything from Twitch?
There's someone with a question here.
Question here. How close can Python get to the kernel? Ooh. I assume you're talking about operating systems kernel here, right? Like Linux kernel or Windows kernel. So the short answer is yes, but not as well. There are functionalities within Python allows you to really get closer to like the memory addresses that you're working with. Um, and I've definitely seen, oh, another question I'll get to. Sorry, Ashley. I've definitely seen like malware being written in Python where we do interact with kernel syscalls, etc. But the answer is you can, and I have seen it happen. You just have to use the right tools for the right job. I think for in terms of Python, Python is also very good for reverse engineering. If you want to get really close to the kernel or really deeply into any program. And you can see a lot of that in tools such as Radar 2 or even Ghidra, for example. Ashley over here has also asked, are there any situational exceptions to KISS? The answer is, yeah, probably. There's probably exceptions to everything where the simplest way you can make something is kind of complicated. So to give you an idea, let's think about something that's very complicated and uh, something that very affects us today, like neural networks. Well, neural networks can only get so simple. These matrix calculations are very complex and they have to be done in a certain way for us to reach the proper like numbers that we're looking for. So you can only get so simple. But the idea here is you want to keep it as simple as you possibly can in order to avoid additional unneeded complexity. Hopefully that makes sense. The point here is to not add more than you need. All right. Any other questions? Wow, I'm surprised my my headset lived. I forgot to charge it. 10 minutes left. Not bad, not bad. All right. I'm gonna check Discord.
If spaghetti is so good, well, why is spaghetti code so bad?
Question from the audience. If spaghetti is so good, why is spaghetti code bad? Wow. For those of you who are not familiar with what we're talking about when we're talking about spaghetti code, we're talking about code that is so complex that it's basically like spaghetti tangled into each other to where you're ending up with this mess of code that's just spaghetti. No one really understands it. Well, it's bad because it's tangled and no one understands it and no one wants to read it. And that's why it's bad. Even though it's really good tasting. I agree. Great question. But yes, do not ignore style. Style is very important. You'll thank yourself in the future. Other people will thank you when they read your code, and you'll thank other engineers and other programmers when you read their code. And all of that will happen sometime in the future as long as you stay in the industry for long enough. Okay. That marks it for today's lesson. So, as a reminder, um, this is probably the end of our lecture portion within our 8-week session. The final week will actually be a like social mixer where we'll all come together. I'm gonna try to show off some of the cool programs and games that I have seen students make within within the past couple of weeks, we'll chat more casually about, anything that you might want to talk about in terms of industry, programming in general, etc. And it'll be a more socialist mixer, so you can get a chance to like talk with your peers and other students around you. All right, cool. That marks today's lesson. Thank you all so much for coming. And I can't thank you all enough for attending, so many of these lectures from both Lucy and I. From the bottom of my heart, thank you all so much. Hope that every single one of you has learned something of value and everyone walks away as a better programmer.